In this video, I'll continue with sort of an overview of what is correlation. We're going to talk about three elements of correlation: direction, form, and strength. So as I just said, when we have a correlation, it typically evaluates three aspects of the relationship. You're going to want to make sure you have these committed to memory: the direction, the form, and the strength, or the degree. So let's go ahead and start with the direction. Every correlation has a direction, and it's indicated by either a plus sign or a minus sign. A plus sign indicates a positive correlation, and that only means that the variables are changing or are related in the same direction. As one variable is high, the other variable is high. And for another person, they might have one variable low, but then the other variable is equally as low. So it means that the direction of the score for both variables for each individual are going in the same direction. Sometimes it helps to look at a graph. So let's look at this positive correlation. On the x-axis, we have temperature from low to high. And on the y-axis, we have beer sales from low to high. And the relationship between temperature and the amount of beer that is sold is a positive correlation in this study, let's say. So what does this mean? Well, it means that if I have lower temperatures, I'm more likely to have lower beer sales. If I have higher temperatures, I'm more likely to have higher beer sales. And this is what this positive correlation, starting from the lower left side and going up to the upper right side, indicates. So this is a temperature of about 50 degrees, and the beer sales are about 25. But as the temperatures get higher, so do the beer sales. This is a predictable relationship. When I know that there's a positive correlation between temperature and beer sales, I can say that lower temperatures are associated with lower beer sales, and higher temperatures are associated with higher beer sales. And so this is a positive correlation. But we can also have what I already talked about before, a negative correlation. And this is when the variables have scores that are in the opposite directions for each individual. So as one score is high for an individual, the other score is going to be low. And let's take a look at what this would look like. So first of all, just to get a sense, the last correlation started in the lower left and went up, and a negative correlation is going to start in the upper left and go down. So this is what a negative correlation looks like. So in this case, we still have temperature, but this time we have coffee sales. And so what this study shows is that higher coffee sales are associated with lower temperatures. It kind of makes sense. People are cold, they go reach for a coffee. But when it gets burning hot outside, people are less likely to drink coffee. So this is a negative correlation. It's still a relationship. We can predict based on the temperature how much coffee sales there are going to be. So in this case, high scores on one variable are related to lower scores on another variable, and vice versa. This is a negative correlation. The next thing we'll talk about is the form of the correlation. And the common form of the relationship that we're looking at is called a linear relationship. And we use what we're going to be coming to know as the Pearson correlation to measure these linear relationships. There are other types of correlations. I'm going to show you an example of something called a curvilinear relationship. But we don't measure a curvilinear relationship using the Pearson correlation because it's only good for linear correlations. So this is what a linear form looks like. Basically, linear means line, and this is not a perfect line. All of the dots are not stacked up on a line, but they're clustered pretty closely together. We see sort of a trend. We see a linear trend here. So this is a linear correlation, as opposed to the curvilinear form. And this is a relationship. It's just not a linear relationship. And the problem is when we're using our Pearson R statistic, it won't detect this curvilinear form. So just repeating, if you try to measure data that have a curvilinear form, basically you're probably going to get a correlation of 0, which is the wrong answer because there is a relationship here. All right, let's go back to the third element, which is strength. So we have the degree of the relationship. We know the direction plus or minus, and we know linear is the form. But how strong is that relationship? How much can we predict one score from the other? What is the strength or the consistency of the relationship? And from this, we get a numerical value of the correlation. That's that Pearson's R that I've alluded to. If we were to have a correlation of positive 1.0, that's a perfect positive correlation. Doesn't ever happen in the world, by the way. But that is the highest limit that you can possibly get, a positive perfect 1.0. A negative 1.0, what is that? You know it. It's a perfect negative correlation. It's when all the dots are exactly on the line. Again, we never see this in the world, but we have this as a potential, a perfect negative correlation. And 0 would indicate that there's no relationship whatsoever, like some scores go together, some scores don't, we can't predict. So this is how we determine the strength of the correlation, is how close it is to either positive 1 or negative 1. The closer we have to positive 1 or negative 1, the stronger the correlation. So let's take a look at some different types of correlations. These are scatter plots, as I've mentioned before, and you can see that the R, or the correlation, is listed here under each of the graphs. So let's take a look at them one at a time. So the first two correlations here are examples of perfect correlations. The top correlation is a negative correlation, but it's a perfect correlation. All of the dots are on the exact same line. They're all going in a very systematic and predictable way. And we call that a correlation of negative 1.00. Down below here, we have a perfect positive correlation, which means, again, all of the dots are on the same line, and the correlation is a positive 1.0. So the next two correlations are examples of strong correlations, meaning, yes, they're not perfect, but they're pretty darn close. I mean, there's not a lot of variation from what would be the perfect line. So this is an example of a correlation of negative 0.94. Now it has negative in front of it, but it's strong, yes. And that is because the negative doesn't indicate weak or strong. The number, as close as it is to either negative 1 or positive 1, is what tells you the strength. And 0.94 is almost, negative 0.94 is almost negative 1, so it's a very strong correlation. And down here we have an R, or Pearson's correlation, of positive 0.86. And so again, a strong correlation. I can draw an imaginary line through the middle, and the dots are not that far away from that imaginary line. You can see that they're a little bit more spread out than this other correlation. So as correlations become less and less strong, the dots start to spread out a little bit more. So here's an example of a weak correlation, an almost non-existent correlation. And as you can see, where would I draw the line here? Would I draw it this way, this way? There's no sense of where this trend is. And you can see the R here is 0.08. It's almost 0. And 0 is as low as you go in terms of a correlation. So if I were to look at a scatter plot like this in correlation, I would say, there's no linear relationship here. I can't really predict one score from the other. And then finally, at the bottom is that curvilinear relationship that we talked about. Look at the R there. The R says 0. So unless I were to look at these dots and I just calculated the R from my numbers, I would think that there's no correlation, nothing to see here. But in fact, this is an interesting relationship in and of itself. It just isn't a linear relationship. Okay. So let's do some learning checks. Which value represents the strongest correlation coefficient? Positive 0.3, positive 0.05, positive 2.52, negative 0.9. Think about it. And the answer is negative 0.9. It's almost negative 1. The negative sign reflects the direction of the correlation, but not the strength. So don't be confused. Negative doesn't mean weak or anything. It just means a direction. Okay, here's one more. Researchers found a correlation of R equals positive 1.20 between coffee consumption and mental alertness. This means A, drinking more coffee correlates with mental alertness. B, drinking less coffee correlates with mental alertness. C, there's a flaw in the computation of the correlation coefficient. Or D, the results are not statistically significant. If you have to pause the computer to think about it, do that. I'm going to switch to the other slide right now. There's a flaw in the computation. Some of you noticed that. We can't have an R of more than positive 1 or less than a negative 1. So the correlation values cannot be greater than 1. Okay, so in the next video, we're going to talk more about Pearson's correlation coefficient.